So I want to return for a second on to Pappert's model then of what microworlds are. We made these graphic representations the other day. So first of all, a microworld has to have tools. So examples were scratch blocks, Legos, turtles and turtle commands, erector set pieces, Dynaturtles, logic gates. I think that the key thing here for Pappert is that these are rich tools for heuristic thinking, that there's not a prescribed end to how these tools are used. They're just there in a rich environment for the user to experiment and create with. So in the context that I was looking at uh, physical circuits. And I think if you look here, so my tools are gonna be across the board some form of power source, which we see here, some form of conductive material. So this is a dime size 3-volt battery. These are conductive material copper tape. I have here, this is a 3-volt LED. The yellow tape is electrical tape, and then the blue background is just a manila folder that I cut in half. So right there, I think the materials, power source, conductive material, output LED are certainly like meet those characteristics of as a micro world. It's very rich, even just with paper circuits. This is very simple, but you can make a very complicated constellation style pattern. You can make a greeting card by the way you fold this. You can do all sorts of things just with this model in terms of what you create. And so I think it definitely meets that part of the criteria. So second part of this is the learner. I do think, my experience in doing this is that I did have more intrinsic innovation in wanting to do this. I wanted the light to light. Play, inquiry, invention, creativity. I did, and as you'll see in further examples, it does make you want to try to make things that are of use that you personally can relate to. Debugging, and that's a key idea I wanted to stress here. And that definitely errors are an opportunity to find out more about the system and the things you can make and how these different pieces relate to one another. So as you can see, it does work. I was a little nervous there for a second, but when I push this down and make contact over here, I have my positive side. The negative side is the bottom of the battery, and when I push those together, I get this thing to light. You can see it's wavering a little bit. I think there's an issue here maybe with the connection here, if that's a good contact or not. But anyway, I think you can see that. So one thing I wanted to look at here, though, just to keep track of some of the kind of errors that I made. So one thing, the battery sliding around. So how was that fixed? Trying to kind of get the right combination to get this taped physically the right way so that when this folded, you'd make contact. That was a second problem. Proper contact not made when this button, because effectively I would say that this is a button. No break in circuit, just putting the LED on top of the copper. So originally I had just kind of stuck the LED out here on this. I have my power connected, I have my loop, and then I'm putting the LED like this. That did not work. We need to have a break in the circuit. The electricity is going to take the easiest path it can. In this case, if I just put this like this, it's never going to go through the LED at all, and the current is just going to keep going the easier way straight on through and not light it up at all. That's why I needed to have a complete break in there and tape this down. Other things to test are, just is an LED burnout? Is my battery dead? And just overall, hey, I put it together and the light doesn't light. How am I going to go about looking at that? Awesome tool was the multimeter, if I'm even pronouncing that right. But so I've got my black sensor here on the bottom of the battery. That's where the negative side is. And then I've got the red here on the top. And I should see this jump over here, that there's a current there. And there it is. So now notice that when I did this on the tape, that's not going to conduct. I don't see anything. So if I'm not paying attention, and now here I've got current in my battery. It turned out that this multimeter was like such a great debugging tool because it really allows you to try things. Do I have current here? Do I have current here? It looks like I've done this right. Where might the issue be? So you can isolate pieces that might be broken. So this is a really awesome tool for debugging in this context.